Welcome back. It is October 13th. We're going to talk about even more word problems. Just got done talking about the rules. Here's the copyright notice again in case you didn't see it the first time. There you go. In the freeware GMAT prep. Okay. When we talk about word problems in general, we have a few other sessions of the same thing. But basically what you got to understand when you do word problems is what causes the trouble that people have with word problems in the first place. Like, in other words, why do people even have this issue? So just to recap a discussion that we had in the previous study hall sessions about this. Like, why, or instead of thinking about why do people find word problems hard in tests and stuff, you should actually think about the opposite, which is why do people find them so much easier in the real world? Because they totally do. Like, when people are dealing with things like spreadsheets and real world balance sheets and stuff like that, most people have much less trouble manipulating those things than they do abstract stuff like test problems. So basically the question that's prompted by that is, why are word problems so much easier in the real world? And we had this discussion in a couple of the earlier sessions on word problems, so you can check those out in the archive if you need to. But basically, when people process math problems, whatever type of math problems they happen to be in the real world, there are two tasks that people successfully separate, and they totally separate these things. Two separate tasks, which are the first one is physically organizing the problem. I mean, this is exemplified by when people make things like Excel sheets. Like, if you think about making a spreadsheet, when you first make a spreadsheet, it is empty. It doesn't have numbers in it yet. And you make the whole thing before you start putting things like numbers and formulas in it. All right, leave me a smiley face if that makes sense. Like, you don't start messing around with things like numbers and relationships until you have a setup. So, I mean, you're not literally making spreadsheets on this test, but this is the step that is like making an empty Excel sheet. So if you think about it, this could be a diagram, it could be a chart, it could be a table, it could be any number of things. Chart, table, diagram, the other organizational device. And you only pay attention to what you need to do that. We'll get back to that in a sec. Then, once you have a chart that exists, once this organizational device exists, you put information into it. There are three kinds of information. There's numbers, there's relationships, and there's the goal of the problem. Just separate steps. Like, again, think about doing these things. They're separate. And then only once you've done all of this, we're going to put this into practice here in a second. So once you've done both of these things, only then pick a strategy and try to solve. Let's put this to work. Let's do a problem. There you go. Remember, you have freedom of how you can organize these. Like in most of these problems, you are not going to be organizing the problem with any kind of memorized template. There's a couple of notable exceptions to this, one of which is the overlapping sets thing. Like those, you're always going to organize in pretty much exactly the same way. But those are notable for that reason. Like in most of these problems, you have considerable freedom as to how you actually want to organize the problem. So there you go. Here's where you are going to pick the multiple choice answers once you have one. Please pick them here. Please do not pick an answer in the chat box. Thank y'all. I'll give you a couple minutes to do that one. Go for it. Okay, please do not write down work in the chat box, guys. The point of this is to do the work by yourself. This test is a solo effort. It's not a team effort. About like 60% of you still don't have answered yet. So if you have to guess, you should guess. Remember the way this exam works. You can't move on. Can't leave questions blank. Can't revisit questions. Can't come back and change your answers later. Can't do any of those things at all. So you have to get used to just picking an answer and committing to it. Okay? Give you like 20 more seconds. Everybody needs to pick something. Okay, let's talk about it. Looks like the answers are mostly A, B, and D. That's alpha, Bravo, and Delta. Alligator, boy, and dog. There's not a lot of people picking C or E. So let's talk about it. Let's talk about physically organizing the problem. I mean, for the most part, physical organization is not some stroke of genius. So make sure that you are not thinking about it as though it is. Like, please do not please do not think that you have to organize these things in ways that are like incredibly genius. Because you don't. For the most part, it's like making a spreadsheet, except less complicated than a spreadsheet, because spreadsheets have many, many, many rows and columns. Like, how did you organize this problem? How did somebody summarize for me in the chat box? There's a way. Yeah, it's pretty much just going to be like a bunch of numbers down a column or something, right? Yeah, pretty much. So either, 7 rows or 7 columns, and that's kind of it. Now here's the even more important part. So no, what you don't want to do yet is anything with 4s and R's and stuff like that. Nope, don't do that yet. Nope. Here, let's talk about colors. Remember, think about why this stuff is easy in the real world. The reason why this stuff is easier in the real world is because people only do the orange stuff when they're doing the orange stuff. And then after they've done the orange stuff, they do the blue stuff. Does that make sense? What color is like they make an empty chart and then they put stuff in it. They don't make a chart and try to fill it at the same time they're making it. Just think about making charts in the real world. Like you make empty charts and then you fill them. The point is that you make the whole chart first. That's the point. Like let's look at what out of this text we actually have to read to do the orange step. Like what do we need? Let me shrink this a little bit. There. Okay. Because I mean, the point is to ignore a lot of stuff each time. Like, what do we actually need to organize the problem? Not a lot of it. I mean, okay, you have first planted. You don't pay attention to the 4 feet right now because that's later. That's a number that goes in a chart. Same thing, constant amount, we don't care right now because that's blue stuff. That's a math relationship. 4 is a number, constant height's a relationship. Just ignore those things. 6 years, and of course you have heights. And then at the end of these years, 1/5 taller than is another math relationship, so ignore it for now. And then that's an orange thing. And then how many feet? Increase it. That's it. Like all we read the first time is the orange box. That's it. You are ignoring everything else. Give me a smiley face if that makes sense. And again, the next time you make a chart for anything in the real world, just pay attention to this. Pay attention to what you actually use to make the chart and what you put off until later. So yeah, we can just do that with 7 rows. 1, 2, 3, 4, 5, 6, 7, see. Let's move all this stuff. Okay. Yeah, there we go. Start. End of year 1. End of year 2. End of year 3. End of year 4. End of year 5. I would actually strongly suggest writing all these things out. It only takes like 5 extra seconds of your life, and it's worth it to not get. Because if you just write year 6, then you might get confused as to whether it's the beginning or end of year 6. If you write this out, there's no confusion at all. Okay, that's an organizational device. Look at that. Not a big accomplishment, but you do it first. Now we do the blue step. So now, yeah, you go back to the problem, and now you're paying attention to everything you did not pay attention to the first time. So it was 4 foot tall. So that's 4 in the start row. What does constant amount each year mean? It means you do what operation from row to row. It's actually not the same rate of growth. It's not, actually. Depends on how you define rate. Could be. That's ambiguous, though. Because when you say rate of growth, that, like when people talk about rates of things like interest, that is actually not the same as this. Like if you have a bank account that has a growth rate of like 5%, that's actually multiplying by 1.05 every time. That's not adding a number every time. The context will not be ambiguous, but you guys should know the word rate could mean adding or multiplying. It depends, right? Interest rates are multiplying, whereas rates of things like per day or per year or per something like that are usually additive. So just make sure that you look at the context and make sure it's clear. So, but you're going to be adding the same amount each year. Okay. Because it's not a constant ratio, it's a constant amount. That's the key. That's what determines that. Yeah, constant amount is a quantity that you are adding to something. You're welcome. Okay. Sometimes people hesitate with this, but what is the only thing that this could really mean? That is 1/5 taller, then that's sort of weird the way they wrote that. But that's clearly not 1/5 of a foot taller, because the smallest number in the choices is 3/10 of a foot every single year. So there's no way this difference could be 1/5 of a foot. And they're not negligent. Like if this was 1/5 of a foot, they would never have forgotten to write foot. So who can tell me what this is? Yeah, it's 20%. Remember, percentages and fractions are the same thing. So if this doesn't make sense to you as 1/5 taller, just write it as an equivalent form that uses the percentage. Yep. So let's say that let's call these things this and that. And we're told that that is 20% taller than this. So if you don't know how to do this, it's in our fraction decimal percents reference, but that's 1.20 times. So that is 1.2. Okay. How do we solve the problem? Couple ways. How can we do it without algebra? Yeah, you work backwards from the choices. Let's try that. Let's back solve. Sure. So you plug in a choice, and you just keep adding it. And then what you're going to check is you're going to check that thing about 1.2. Because that's the only other fact in the problem. But notice, notice how not overwhelming this is when we've broken it up into the orange steps and the blue steps. It's like very tractable. It's very doable. These things are only overwhelming if you try to do the orange and the blue step at the same time, guys. Okay, let's try to do this. If you add 1/2 a foot every year, this would be 4.5. This would be 5. 5.5, 6, 6.5, 7. 7 is not 20% more than 6. So that's incorrect. Okay. Well, no, it's not. Remember, in fact, if you are adding a constant amount, then by definition, it's not a constant percentage change, and vice versa. Because if you think about it, this is in response to Sandeep's question. If you're adding the same amount, like imagine you have a kid who grows like 3 inches a year. Like when that kid is still a small kid, that 3 inches is going to be a pretty big percentage of that kid's height, right? But when that kid's an adult or a teenager who's like 5 or 6 feet tall, it's going to be a much smaller percentage. Versus if you have a percentage growth, then that's going to be a more and more height per year the taller the kid gets. So no, it has to be one or the other of those. It actually cannot be both unless it's 0%. So let me get a smiley face, that makes sense. Cool. All right, so these are not right. The next ugliest fraction to me would probably be the 2/5, because at least those are terminating decimal. So I'd go for that next. I'd go for the 2/5. That's 0.4. So that's 4.8. That's 5.2. That's 5.6. That's 6, and that's 6.4. So, okay, is 1 point, remember all you're checking is whether 1.2 times 5.6 is equal to 6.4. You don't need to work this out all the way. Like if you set this multiplication up, just like think about it, right? If you're like, okay, 1.2 times 5.6. I mean, the first step is going to give you a 2 here, and then you get some digits up there. And then it's like blah, 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 blah. And then you're going to have 2 decimal places. In other words, it's going to look like that. That's not 6.4. So I don't care what this number is, because it's not 6.4. Smiley face if that makes sense. This is another big mistake people make when they do things like back solving and smart numbers, is they actually work out all the calculations all the way, instead of remembering that the goal is just to see whether they work or don't work. Like as soon as you realize that this is not going to be 6.4, there's 0 reason to keep doing it. So yeah, that's not right. If we do 2/3, sorry, 2/5, 2/3. That's gonna have to keep those as fractions. So that's 4. That's 4 2/3. That's gonna be 5 1/3. That's going to be 6. This is going to be 6 2/3. This is going to be 7 1/3. And this is going to be 8. So the numbers we're looking at, which are 6 2/3 and 8. So 1.2 is a fraction now. So 6/5. So is 6/5 times 6 2/3. 6 2/3 is 20/3. Is that equal to 8? Well, 6 over 3 is 2. That's 40 over 5. That's 8. Look at that. We win. So it's D, dog. No algebra necessary. You can do algebra. Of course you can. Any questions about this non-algebraic method? Smiley face, this makes sense. Smiley face thing. Cool. All right, let's do it with the algebra super quick. There's a blank version of that chart again. Okay. If you do it algebraically, you might as well let X stand for the growth rate, or the growth amount each year, because that's the thing you want anyway. So this would just be 4 plus X. This would be 4 plus X plus another X. And so on. You just keep adding X. Again, notice the same organizational device is great, right? Like you use it, it's the same thing no matter which strategy you pick. So if you use that as 1/2 times this, 4 plus 6X. Sorry, it's not 1/2. 1/2. Yeah, I'd rather use fractions for that. With algebra, it's usually easier to deal with fractions. Notice the skill set of being able to go back and forth between fractions and decimals is super important here too. Like you gotta be able to kick it back and forth between 1.2 and 6 over 5. There can't really be hesitation there. So let's multiply both sides by 5. That gives us 20 plus 30x is 24 plus 24x. Do a subtraction. And there you go. Any questions? Remember, when you review the problem, the single most important thing you can do when you review problems is not let yourself do whatever you did the first time. So if you did algebra the first time, make yourself back solve when you review. If you did back solving the first time, make yourself do algebra when you review. Whatever it is. The point is to develop a diversity of solutions. Okay, let's do it. Problem. How about I just realized I was off the mic. Don't forget to separate these tasks as best you can. Don't forget where the multiple choice answers are located. Have fun. There's only 5 people with answers. It's not a lot of people. I mean, remember, this should not be the kind of thing where when Ron is like, guys, gotta answer the question, like 3/5 of you start pouring in the answers. I mean, remember how time management works on this test. Time management is basically just you admit when you're stuck and you quit. That's basically all it is. Okay, let's talk about it. You get an interesting answer distribution. Got almost even numbers of people picking B, C, and E. And then no one's picking A or D. Let's talk about it. Let's organize it first. I mean, some sort of organizing, right? Something that can help you make this less overwhelming. Because, yeah, about 2/3 of people got this wrong, so something is clearly an issue. Let's talk about organizing it. What's happening in problem? Like, what is the problem asking you to do? Yeah, it's asking you to simplify a formula. So it's like a procedural thing, right? How would you map that out? How would you map out the simplification of a formula on, like, everyday normal planet Earth? How would you do that? You could make a chart, yeah, with the different parts, and then you could, like, make a... I mean, I'm sure that some of you guys in the jobs that you do would probably call this a workflow or something like that, or a flow chart, something. It's basically a workflow. I mean, you take stuff and you do things to get it simplified stuff. So it's like a workflow. So the orange thing can just be setting up a workflow. A chart with different terms, yeah, right? So, and again, you don't worry about the specifics because that's the blue part. So you're going to add something, don't care yet, to the average of something I don't care yet and something else. I mean, honestly, that's kind of all you care about right now, is that. It is and it isn't, because reading comp is not this detail-oriented in a specific way. Like, you wouldn't, if it was reading comp, you wouldn't be paying any attention on this level of detail. But on a certain, I get what you're saying, which is on some level of analogy, that's true. Like, you're kind of, to whatever extent there's like a main idea of the problem, you're kind of looking for it. That's kind of an interesting way to, and that's actually a very insightful way to think about this. Yeah, it's kind of what the deal is. You could think of it as an orange thing as like a main idea of problems. Actually a very cool way to think about it. The main idea of this problem, yeah, is you're going to take something and add it to the average of something and something else. You guys know how to take average things. You add them, and you divide by 2. That's not that hard. It's only hard if you try to do everything at the same time. That's when it gets hard. Now you go back and figure out the rest of the detail. So the I is defined at the end of the problem. So this is just 2% of I. We haven't done anything with that stuff yet. Like literally, Sandeep, haven't even touched it yet. Like we have only. I mean, let me white out the words just to make this point more emphatic. Like we have only looked at these words. Like the numbers 100 and percent, those kinds of things don't even exist yet. That's all we got right now. That. Because that's, I mean, at a large scale, that's all you're doing, is you're adding blah, 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 blah to the average of blah, 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 and blah, 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 blah. And then you figure out what the blah, blah, blahs are. That's the point, though. If there's different layers of stuff, don't pay attention to more than one layer at a time. Okay. So 2% of one's annual income is 2% of I. Should probably do it as fractions, because these are fractions. These are not decimal. So probably do these as fractions. So that's 2I over 100. Which is the same as I over 50. Okay. And then you're taking the arithmetic mean of 100. Is that clear to you guys now, Claire? Sandeep, are we good? So level of looking at one layer of meaning at a time. It's you know, if you had to do this on a tax form, I'm sure you guys would be all over it. You're like, okay, just to figure this deduction. You gotta take this thing from line 36 on form 1040A and add it to the average of this form from schedule E and this line from form schedule as E. You guys would be fine with that. It wouldn't be overwhelming. Try to just bring in the same intuition here. So, how's my sound, everyone else? Is my sound messed up? Okay, good. 100 units of currency is just literally 100 units of currency, so that's 100. And then 1% of the annual income is just I over 100. So, all right. Sure. Okay. You guys know how to deal with these fractional expressions. I mean, you can just multiply the top and bottom of this by 2. Or you can actually multiply by 100 to get rid of that. Sorry, not 2. 100 to get rid of the small denominator. That gets rid of the picture-in-picture fractions, so to speak. So we'll leave this one alone for a second. I over 50 plus. This is going to be over 200 now. That's going to be 10,000 plus I. And a common denominator. Common denominator is 200. So that's going to be 4I over 200 plus all this stuff. So that winds up being 5i plus 10,000 over 200. Which answer choice is that? And how much of this do you have to pay attention to? It's going to simplify to one of the choices, though. I mean, which is the only part we have to look at. Remember to always be doing this with your heads up. Like, some people are looking at 10,000 over 200 first, but that'd be a mistake. Because these are 5 different I terms. If you figure out the I term is, sorry, 3i over 100 is the same in B and E. But if you get anything is not 3i over 100, you're done. So you could pick numbers, although if you did pick numbers, in this case, you would not circumvent any of the work. Because when you review the problem, you should still make sure that you can do it. But you would still have to run those numbers through all of this. The main advantage of doing that would be that you would no longer have to deal with fractions inside other fractions, which might annoy you. But it doesn't save you as much work as it normally does. But when you review the problem, you should absolutely try it. So this is I over 40. It's I over 40 plus stuff, so you're done. So that's choice C. So make sure that you do that with your head, your head's up. Like this is a lot more different things here. So you would start here. Gives you better chances to actually eliminate that. Any questions about this? Try the picking numbers at home on this problem. Make sure you can do it. I mean, it would be literally the same process. You would be picking a number and running it through the same sequence of steps. The only advantage being that you would no longer have to do things like common denominators and fractions. Like if I was 100, well, let's just do it. Let's say you pick I as 100. It won't take any longer to do it, and we'll talk about it. So if you pick I as 100, then this is going to just be 2. Plus that average works out to be 100 plus 1 over 2. And that's not amazingly beautiful, but let's see where it goes. Okay, let's get these out of here. So that's 2 plus 101 over 2. That's 2 plus 50.5. So that's 52.5. And then remember, you picked I as 100. And then you have these choices. So you can see where the trade-off is. I mean, the trade-off is you don't have to do fractions anymore. So it's clearly not D or E, because those are more than 100. And then this is 50. This is A is 50 plus 1/2. That's only 50.5. B is 50 plus 300 over 100. That's 50 plus 3. And this is 50 plus 100 over 40, which is, that's 50 plus 2.5. There you go. So you can also pick numbers. Any questions? Smiley guy, if that makes sense. And remember, when you review, goal is to come up with as many ways as you can. Let's do another one. Let's see. How about this one? Okay, you know where the multiple choice answers are. Please do not type text in the chat box. Go for it. Currently, two of you have a choice that is logically impossible selected. So don't do that. Don't pick impossible choices. Looks like we got a smart aleck in the chat box. Gotta pick something, guys. Does anybody know which is the impossible answer choice? Actually, that one's impossible too. Yeah, that one's also impossible. Here. You know where the answer choices are by now. Let's say that I didn't even tell you what the question was, and I was like, blah, 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 question mark. Sorry, question mark comes later. Blah, 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 period. Which of the following must be true? Roman numeral 1, Ron is between 0 and 80 years old. Roman numeral 2, Ron is between 20 and 80 years old. Roman numeral 3, Ron is between 10 and 40 years old. Can anybody tell me something about these three statements? Like, if you know, like, which one of these can't be true without also making another one of them true? Yeah, if either, like, if 2 is true, then so is 1. And if 3 is true, then also so is 1. So 2 without 1 is impossible. And 3 without 1 is also impossible. Let me just not think if that makes sense. This is the same thing. These are more annoying looking because they're algebraic quantities, but you should definitely not have picked B or C to this problem. The other choices are at least logically consistent with themselves, but yeah, like if you found out that Ron had to be in his 30s, for example, then all 3 of them would be true. that sort of thing. Okay. So, but you definitely shouldn't have picked B or D, or sorry, B or C, because those are not things. Those are not possible. Okay, now let's actually do the problem. Okay. Orange stuff. Let's organize. Orange is figure out what's happening in organized problem. Okay. So you have two fixtures. What happens when they give you something alone would take a certain amount of time? What is that really giving you? This is something you should recognize instantly. It's very important to recognize. That's a rate statement, exactly. Like if I say, notice that nothing actually takes C hours in this problem. That's important to understand. Like if I say that I would take 5 hours to paint a whole house, I'm not doing anything for 5 hours. What that is, that's a rate. That's all it is. All I'm telling you is how fast I work. So, like same thing, I could type 300 pages in 7 hours. That doesn't mean I'm going to actually go type 300 pages. I'm just telling you how fast I can produce it. So, this is a rate. If that's not instant recognition, you should definitely practice that recognition. Just flip through a bunch of problems and see if you can recognize that that's a rate. It's 1/C buckets per hour. Okay. The hot water, same sort of thing. Would fill it. That's another rate. And then like at the same time. So you're going to be adding some rates. Okay. There we go. I mean, for rate problems, you might not even need a whole formal chart, because if you know that this is a rate of 1/C buckets per hour, it's a rate of 1/H buckets per hour. And you might not even need the physical whole chart and stuff. But so the cold tap alone, the rate is 1/C buckets per hour. And then the hot tap alone is 1/H buckets per hour. So what do we do with this thing? What would you guys do with that? Yeah, well, first so you want to figure out where you got that from, right? Like the point is to add the rates. That's really the only like relationship we need here, right? Just add these. So the combined rate. So picking values is dangerous, or at least you have to be very thorough about it, because when it says must be true or could be true, that means you can't just pick one set of values, because you would actually have to systematically and exhaustively test these things. when you review the problem, you should make sure that you do that, but that is not necessarily going to be efficient, but you should try it. So the combined rate is the sum of these. So it's 1 over C plus 1 over H buckets per hour. So common denominator, that's going to be H plus C over CH. Okay, I mean, no, yeah, picking values is just as good, sure. So then you have rate times time is for 1 bucket, which is what we want. We want that. So it's that thing, rate times buckets per hour times hours equals buckets. Remember, the point is not does this save time. The point is to accumulate as many ways to solve these things as you can. You don't want to think about does it save time. You just want to do stuff and not do stuff. The worst thing that you can do is think about whether stuff will save time in the middle of doing it. So that's going to cost you dearly. Because what that'll do is make you just reluctant to do anything. Careful with that. H plus C over CH times T to think of solving for. Okay, so if you solve that, it's CH over H plus C. Okay, now that's the T. There you go. How do you tell whether it falls in these ranges or not? Well, you could start throwing values at it. And again, when you review the problem, you should make sure. But you don't need to plug in anything. No. And what if these were just normal fractions that weren't fractions with letters in them? Like, how would you tell? How would you tell if like 3/7 was between 2/5 and 1/2? And remember that these are still fractions. I mean, they have ugly letters in them instead of numbers, but they're not any less of fractions than they used to be. I mean, how do you tell if one fraction is between other fractions? Yeah, cross multiply that. I mean, not there's 3 of them. Like here, if you remember that cross multiplying is fundamentally not a thing anyway. Like, what are you doing when you cross multiply? You should know what you're doing. Like, basically, is this? We want to know if this expression fits in this range or not. How do you tell whether this is true? Yeah, that's how you just make a common denominator, guys. It's exactly like having regular fractions. If this was like 3/7 and this was 1/2, and I wanted to know if 5/11 or something was in there, I would just, you can't cross multiply because you have 3 fractions, but you could just give them all the common denominator of everybody. So, yeah, sure. So Let's give everybody down here. So these two have also have h plus c. And then these have to be multiplied by 2. All right. So this becomes, everybody's over the same denominator now. So is hc plus c squared less than 2ch hc, which is hc plus h squared. The work for that was on the board for a while. If you want to check the recording when they post it, then because I already killed it. The work is still there, actually. I think it's underneath this whiteout. Yeah, it is. So I can uncover that later. If you want to see that after we're done, I can just uncover it. Notice this is hc plus hc. So this is absolutely true, because h is bigger than c. So c times c is going to be less than, the hc's are all the same. These left-hand terms are the same in all three. And then if you compare these guys, that's true. C times C is less than H times C, which is less than H times H, because H is bigger than C. So 3 is yes. And it looks like we're done because it's E. It's the only choice left that has I in it. Cool. You know what else you can also do? See, okay, this is kind of a lot of work. And what they do, you should also, when you review, you should also test numbers, but that's a lot of work too. You should also test numbers, but that's not going to be a panacea here. This will also be a lot of work because must be true means you have to test enough values to convince yourself that I is always going to be true. Well, if 3 is true, then we're done because it's the only choice left that has 3 in it. 2 is wrong because the choices. I mean, you would do 2 the same way. You would just line it up like this and give it a common denominator H plus C, and then you would. Less than H would definitely have to be true because in fact this is less than half of the H, but greater than C would not have to be true. So this inequality would not work. But there's also, like, when there's this much work in the problem, you know what else consistently happens? So a lot of the time you can just be like, yo, common sense. That's a thing. Do that a lot of the time. When there's this much stuff happening in the problem, always think about common sense first. I mean, I've seen problems where there's like back-breaking amount of work, but if you actually, the answer choices had like square roots of 3 and pi in them and stuff, and it was like, how much area is this grass field? And if you actually estimated the numbers, then 4 of the choices were negative, and only one of them was actually a positive number. So like, if you bothered to do that, you'd be like, I don't even have to do the work. That's kind of cool. Remember, these choices are logically impossible. It doesn't matter what the level is. You should never think about that. That's not a thing. Okay. Remember, these are logically impossible. Okay. Let's just think about this with common sense, guys. If you had 2 of these taps, the C hour, how long would that take to fill the whole thing? If you had 2 of those. Instead of 1. If you have 1 of them, it takes C hours. If you had 2 of those, how long would it take? It would take half the time. Yeah. If you had 2 of these taps, it would take half the time to fill the thing. Smiley face if that makes sense. Basically, if you have 2 of anything working at it, so you're twice the rate, you're going to finish in half the time. Oh, but wait a minute. That's the fast tap. Because C is less than H. This is a faster time. So these 2 pipes will take longer than that. Oh, what's that? What about the H hours? We had 2 of those. Same deal, right? If you had 2 of these things, it's going to take H over 2. Same kind of reasoning. But this is the slow tap, so you're actually going to be faster than that. The 2 taps we have together will be faster than H over 2 hours. Oh, look at that. That's beautiful. We just solved the problem. Thing. And when you review the problems, you should, I mean, if you ever find that a problem involves just an annoying amount of busy work, and that even when you do non-algebraic methods, that it still involves an annoying amount of busy work, then you should, when you review, you should really think, like, is there a way I can just smack this problem with common sense? Because there probably will be. That's a thing these guys do. So be aware of that. I mean, because in this problem, both the algebra method and the testing numbers method are lots of steps. So they will build in either one of the methods, like back solving or smart numbers or what have you, will be fewer steps, or like it'll be super efficient. Or you'll have something like this where you can just like think about it and be like, oh yeah. Boom. But think about this when you review. They do this, the thing. So then if number 3 is true, then you're finished because the choice is, right? So you don't need to think about it. You can also, you know, if you think about these things, like it's not going to take you longer with 2 tabs. You can also realize that statement 2 is false. I mean, that's also common sense because C is how long the cold tap takes alone. So if you turn on the cold tap and anything else, then it's definitely going to take you less than C, right? So eliminating 2 is even quicker because this is how long the cold tap takes by itself. You have the cold tap and another tap. So C is definitely less than C. So that's out. There's no should. I mean, you should try whatever comes to mind first. It's going to be a combination of your personal skill set and also random inspiration. I mean, like if you wake up one day and you feel like picking numbers, you should pick numbers. If you wake up one day and you feel like doing algebra, you should do algebra. You just do stuff. I mean, again, this is not a back-breaking amount of algebra. I mean, it's not. This is still very doable. I mean, this is not, oh my God, it's going to take me all night. So that's not the point. The point is that you can still collect lots of other ways to do these things. But you should always just, first thing that pops into your head, you just do it. You should never think about, is there a faster way? You should never think about, is there a better way when you are under timing conditions. Don't do it. I mean, if you can think of a situation with common sense, of course you should always do that first because common sense doesn't take time. I mean, if you have this insight, you'll have it quickly. So if there's anything you want to try at the beginning, it would be that. Which in the real world we just do that, right? Like when you face a real world problem, you make a common sense estimate first. Like if you're doing a tax deduction, you probably have some idea how big the deduction should wind up being. Yeah, like if you take a deduction that was $12,000 last year and you have about the same income, and suddenly it's like $42,000, then you probably made a mistake. Like that. But otherwise, you just do stuff and don't not do stuff. Okay, I gotta run, but we've got another one of these in 2 weeks. So, thank you. Good evening, good morning, good night. It might be verbal, it might not. No one knows, man. I don't know what the themes are going to be until literally about 45 minutes before we start. So it's not next week. It's the week after next. So, okay, going to kill the recording.